This is Algebra 1, Week 2, and it's a review of prime factorization, find the greatest common factor, and finding the least common multiple. When I talk about finding the factors of a number, I am looking at the numbers that go into 12, numbers that I would multiply with other numbers to get 12. So with the factors of 12, I have a list 1, 2, 3, 4, 6, and 12. Now a quick check to make sure you have all of them listed, if you've got them written in order, is just to pair them up. 1 times 12, 2 times 6, 3 times 4. That's a complete list of the factors of 12. If I'm looking for the factors of 36, I'll do the same thing. 1 times 36, 2 times 18, 3 times 12, 4 times 9. Now, if I end up with a number by itself in the middle, then that means I take that number times itself to get 36. So as long as I have a pair for every set of numbers, then I've got all the factors. Alright, now let's talk about what is termed prime factorization. Basically what that means is I'm going to break down 12 into factors, but I'm going to continue to break it down until I can't break it down any longer. For example, 12 is 2 times 6. 2 times 6 is not the final answer because I can break 6 down into 2 times 3. So I'm going to bring the 2 down because it's done. And my final answer is 12 can be broken down into 2 times 2 times 3. Now, at the bottom here, when I look at these numbers, they should all be prime numbers. Prime numbers are the numbers whose only factors are 1 and itself. So at that bottom row, you should never have a number that you could break down further. Okay, now on the left I have what we just had on the screen, how we broke down 12. Now what if you decided instead of 2 times 6 that you wanted to think about 12 as being 3 times 4? Well, the 3 is done, but that 4 can be broken down into 2 times 2. Now if you look at your two answers, they're the same. Now in order for us to compare the answers easily, what we do for our final answer is we write the numbers in order, smallest to largest. So I would say 2 times 2 times 3. Or an even more concise way to write it would be to say 2 to the second, because there's 2 of them, times 3. Either one of these is acceptable for your final answer. Alright, now let's say you have a larger number like 360. If I break that down, there are lots of different ways. If it ends in a 10, a real easy one to start with would be 36 times 10. Then keep going. 36 is 6 times 6, and each of those can be written as 2 times 3 and 2 times 3. And this 10 can be written as 2 times 5. So once you're done, bring them down to the final row so that you have a good look at what you have. I have got 2 times 2 times 2 times 3 times 3 times 5. Or a simpler way to write it is 2 to the third, because there's 3 of them, times 3 to the second, because there's 2 of them, times 5. There's your final answer. Alright, now on this screen I have listed the factors of 12 and the factors of 20. If I want the greatest common factor, I look at the list and find the factor that's common to both lists and is the largest one. Here we go, it's 4. Now, there is a common factor of 2 and there's a common factor of 1, but I want the greatest, that means the largest common factor, which would be 4. Now these numbers are small enough where you could probably just think through the different factors and come up with the largest one. But we're going to do another example now that have numbers that are much larger, so we're going to have to break them down into their prime factorizations first. Okay, I'm looking at the number 30 and the number 84. And if I want the greatest common factor for those two numbers, I don't know about you, but it doesn't come to mind fast for me. So what we're going to do is we're going to factor both of those numbers into their prime factorization. Okay, here you see that I have the prime factorization of 30 and the prime factorization of 84. I want the greatest common factor. So I'm going to look for things that these have in common. Now I see this one has a 2 and this one has a 2, so I'm going to write it down. Then I'm also going to notice that this one has a 3 and this one has a 3, so I'm going to write that down. There are no other common factors, so I multiply those two together and get 6 as my answer. Now notice there's a 2 here, and I have another 2 in 84, and I have another 2 over here. But it's a 1-for-1 connection. If you circle 1, 2 with the number 30, you can only circle 1 with the number 84. It has to be common to both. So you write down the factors they have in common, and you multiply them to get your GCF equal to 6. Okay, now let's take a look at multiples. Multiples of a number are the numbers I get when I take 1 times the number, 2 times the number, 3 times the number, and so forth. So the multiples of 4 are 4, 8, 12, 16, 20, 24, 28, and on and on and on. That's what those 3 little dots mean. Factors of, or the multiples of 6 are 6, 12, 18, 24, 30, 36, and so forth. So if I want to find the least common multiple, I'm looking for the least or the smallest common multiple. So now I look here and I see a common multiple of 24 and I see a common multiple of 12. Those are both common multiples, but I want the least common multiple, so I want to write down the number 12. The smallest number that both 4 and 6 will go into. That's called the least common multiple. Okay, here's another set of numbers, 8 and 10. Now I don't have to list all the multiples of 8 and 10. I can just think about those numbers and say, okay, what's the smallest number that both 8 and 10 will go into? Now an obvious choice would be 80, because you know 8 times 10 would have to have both 8 and 10 as factors. But there is a smaller number, so think of the numbers, think of your multiplication tables, and write down the smallest number that they will both go into. That number is 40. Okay, now what about 12 and 90? I have no idea what the smallest number that 12 and 90 would go into. So for numbers that are too large for us to just kind of do in our heads, we're going to start with the same thing that we did before. We're going to write the prime factorization tree for both of the numbers. Okay, now I have the prime factorization of both numbers listed here. Now I'm not looking for the GCF, the greatest common factor. I want the least common multiple. So here's how you do that. You write down all of the factors of the first number. 2 times 2 times 3. Okay, now that represents the number 12. So as long as I have 2 times 2 times 3 listed, I know 12 will go in there, because 2 times 2 times 3 is 12. Now for the 90, you need to put down only the numbers that are not already there. For the number 90, I need a 2, 2 3s, and a 5. Well, I've already got a 2 and a 3 listed, so it looks like I only need one more 3 and a 5. Alright, now let's see how this works. Right here, that's the number 12. So 12 is in my LCM. I need that to be true. Now this right here is the number 90. So 90 is in my LCM. As long as you see all the factors of both, when you multiply them together, both 12 and 90 will go in there. Now to finish the problem, I just need to multiply all of those numbers together. A quick way to multiply the numbers would be to see where you have the 90 represented, and if you take 90 times the other 2 that's there, you get 180. It doesn't matter how you want to multiply those numbers together, you get 180. So the LCM of 12 and 90 is 180. 180 is the smallest number that both 12 and 90 will go into. Okay, here's our last example. I have the numbers 20 and 36. If I'm looking for the greatest common factor, I'm looking for the largest number that will go into both of them. Now the 20 has 2 2's and a 5. So it looks like they've each got 2 2's, and that's all they have in common. So 2 times 2 is 4. That means 4 is the greatest common factor. Now for the LCM, remember, you automatically just write down the first one and then write down what's missing from the second one. The second one says I need 2 2's and 2 3's. I've got my 2 2's, so I need to put the 2 3's, and when I multiply all those together I get 180.